In this video, we are going to solve an integral involving trigonometric function. Here is a problem. We have evaluate the integral of secant x divided by cotangent to the fifth x dx. So let's see if we can rewrite the integral in terms of sine and cosine, then we will obtain the following. So integral of secant x divided by cotangent to the fifth x dx. Remember, secant is 1 over cosine. So 1 over cosine x divided by cotangent is cosine x divided by sine x. So all this to the fifth dx. Simplifying further, or making it one integral or one fraction, then we get sine to the fifth x divided by cosine to the sixth x dx. Okay, so and this can also be written as integral of sine to the fifth x sine to the fifth x cosine to the negative 6x dx. Now, if we can convert it into use a property, the rule for integrating sine to the n, cosine, and so on, so we should be able to get this done. So remember, sine to the fifth is sine x times sine to the fourth x, then you have cosine to the negative 6x dx. Now, and sine to the fourth x is sine square x, or that square, in other words, is 1 minus cosine square x, or the square, that means 1 minus 2 cosine square x plus cosine square x squared, that is cosine to the fourth x. Now, replacing sine to the fourth x in the integral will obtain the following. Integral of sine or secant x over cotangent to the fifth x dx is, now, okay, what do we have here? Move on a little bit. Integral of sine x, the parenthesis 1 minus 2 cosine square x plus cosine to the fourth x, all this times cosine to the negative 6x dx. Now, why are we doing this? We see that we have one sine x in there, and we know that the derivative of cosine is negative sine. Therefore, if we have only sine x times cosine to any power x dx, then we are done. We do the change of variable u equal cosine x. Now, this simplifying, we can write it as a sum, a linear combination of integrals. So sine x cosine to the negative 6x dx minus 2 integral of sine x. Now, cosine squared times cosine to the negative 6 is cosine to the negative 4x dx, and plus integral of sine x cosine to the negative 2x dx. As we said, if we say u equals cosine x, that means that implies that du is equal to negative sine x dx. Okay, so it means that sine x dx is negative 1 if you want times u. More here, right? Sine x dx is negative 1 times u. Now, using this in some of these, in each of these, we get integral of secant x over tangent or cotangent to the fifth x, x over cotangent to the fifth x dx. We said it is the integral of sine x, okay, sine x cosine to the negative 6x dx minus 2 integral of sine x cosine to the negative 4x dx plus integral of sine x cosine to the negative 2x dx. Okay, now in each of them we can replace sine x dx by negative du, so the negative integral of cosine x is u, so u to the negative 6 du. Now plus 2 integral of, now remember plus 2 because the sine x dx is negative du, so the negative 2 times negative 1 is 2. So, and then u is, cosine x is u, so u to the negative 4 du minus integral of u to the negative 2 du. And from here, everything becomes easy. So negative u to the negative 6 plus 1 over negative 6 plus 1, using the basic rule of integration of polynomial, plus 2 times u to the negative 4 plus 1 divided by negative 4 plus 1 minus u to the negative 2 plus 1 divided by negative 2 plus 1, then plus constant. Now replacing u with, simplifying and replacing u with what it is, that means cosine x, will get negative, or negative 1 divided times 1 of negative 1 over 5, 1 over 5 u to the negative 5 minus 2 over 3 u to the negative 3 plus u to the negative 1 plus constant. Now let's first simplify that way, and that's a 1 over 5 times secant to the negative, sorry, secant to the fifth, 1 over 5 secant to the fifth x minus 2 over 3 secant to the third x plus secant x plus constant. Now the y is that because you have u to the negative n is 1 over u to the n. That means 1 over cosine x to the n. That means secant to the n x for when, for any n integer, positive integer. And this concludes the problem.